Hello everyone, welcome to Full Stack Software Testing from Scratch course session 1. So I'll be creating a complete playlist for software testing in case you want to learn software testing in depth by following step by step process. You can refer all the video one by one, and I can guarantee that you can able to gain the good confidence in software testing, starting with the requirement analysis to design the test cases, creating the RTM, creating the scenario, creating different test artifact like test plan, test strategy, test summary report, along with the functional requirement document user story, and also you'll be having the good knowledge in defect management, different testing methodologies. So all these will be covered in step by step way. So in today's sessions, I'll cover couple of important topics from the software testing, like what is software and program, software development lifecycle or SDLC, software architectures layers, key importance, popular SDLC model available in the market, software testing overview, and why software testing is necessary in the real-time world. Then we'll discuss about the error, fault, and failure. How can error occur in the system, and what are the key software testing principles. Then we'll learn about the software testing lifecycle or STLC, and then we'll discuss about the key test deliverables by QA team across STLC, which need to be shared with the respective stakeholder. Then we'll learn about the key important functional and non-functional testing type, along with the differences between functional and non-functional testing type. So, in case you are having some idea in the real-time information technology sector or IT sector, so you already know there are a lot of teams working in the information technology sector. There is development team who is primarily responsible for developing the product. There's a testing team who is primarily responsible for all kind of functional, non-functional testing and manual and automation testing as well. There may support team who are really responsible to provide the support of the product or the program or the software. There are the business analyst teams or the subject matter expert who are responsible for dealing with the requirement, and there are a lot of other teams also involved in the IT sector like the admin, HR, networking team, like that. So let's start with what is software and what is program. So software is a collection of programs designed primarily to perform specific tasks or solve the problem. And program is a set of logical instructions given to a computer to execute operations automatically. So program is part of the software, and so combining all the programs like software can be designed. Okay, so software is the entire systems. Suppose in case you are working in the Microsoft Office, in the Microsoft Office there might be Microsoft Excel, Word document, Microsoft Outlook, all this stuff will be there, and it is completely entire system. Whereas a program is nothing but a specific module within the system. Like there are different tool like spell checker or other tool might be there to deal with the different Microsoft Office system. So these are small component is nothing but the program. An entire component as a together is nothing but the software. So software is complex, requiring development, testing, and user documentation, whereas a program is generally smaller, simpler, and focused on a single functions or single objective. And where your software is nothing, all the objective, all the functions are built together to create a software. So there are important categories of software available in the world, real-time world. The key important categories I have tried to just mention in this document, like web-based software, desktop-based software, mobile-based software, embedded system softwares. So web-based software, most of us nowadays we are using our laptop, our desktop, our tab, right? So some most of the time we are interacting with the browser, and we are trying to access different applications like Google's, Facebook, different banking apps. Okay, so these are the software we can try to run in different browser. It can be Edge browser, Chrome browser, Firefox browser, and whenever you want to work with this web-based software, you require the internet access. Without internet access in the offline mode, you cannot access it. Then desktop-based software, It is primarily installed on personal computer like antivirus, Windows, different operating system, MS Office, etc., and can run locally without internet connection dependency. So whenever you need to install, that time might be required the internet connections. After that, without internet connection also still you can install it and you can work, proceed your work with this desktop based software. Then mobile based software is there. Nowadays most of our are using different Android phones, iPhones, mobile, where we can install different software via the like app store like Instagram, WhatsApp, right? And different other system also like installing in the mobile apps. So uh, like it is primarily used to optimize for mobile platform. Then embedded system software also there, which primarily run on specialized hardware. And they are typically lightweight and task specific. So a couple of example for the embedded system software is like that, like routers, okay, set-top box, different medical equipment or devices, ATM card reader. So these are the embedded software which runs on a specialized hardware. Then let's understand about the SDLC process or software development life cycle. So software development lifecycle or SDLC is nothing but a structured process that ensures software is delivered with quality, means without sacrificing any kind of quality. So with quality within the budget. So whatever budget is that, definitely within the budget you need to follow it, and on time. Ranging from initial planning to maintenance, it consists of couple of phases. So whenever you are doing any kind of development, so couple of main important things we need to remember, that we cannot compromise with the quality. We need to just maintain the budget. We need to maintain the schedule, right? And then that software development will go with the couple of phases step by step. So there are a couple of phases available as part of the SDLC life cycle, like requirement analysis, design, development, testing, release, and maintenance. There might be more depending on the project type, depending on the customers, depending on the stakeholder. It might vary also. But this is the more or less a similar pattern every organization or every customer will be following. So first is like requirement, where like the development team will try to gather the business and functional requirement from the different stakeholder, and then they will start the analysis where they will study the requirement. They will identify the feasibility, and they will define the scopes. Here they will try to understand what can be developed, what cannot be, like in and out of scope of item, right, with all the logical feasibility. Then they will start with the design, where they will try to create, a development team will try to create the system architecture, database schema, flow chart, or high level document or low level document, design document. Once this step is done, then they will start with the development, because they already get the proper clarity what is the like design pattern they are using, what are the requirement they are following, and what are the in scope item, right, they are trying to develop. So the development phase will start. Then they will development team will try to write the code using the like required or chosen programming language and framework on the design specification. That programming language can be anything like Java, .NET, right? Python, JavaScript, or TypeScript, and any relevant framework specific to the programming language, and different supporting tools also will be there to develop the code, right, using the chosen programming language and the framework. Once development is completed, then they will hand over the code to the testing to certify that, right, all the intended functionality is implemented correctly, and testing team will go with like set of different functional and non-functional testing, and they will certify the product. So in the testing phase, like QA or the quality assurance team will validate the functionality against requirement through manual or an automation testing. Apart from that, they will perform different non-functional testing like the performance, security, right? All this stuff will be there. Then once like development testing is completed, they will go for will release, where DevOps team also can interfere to deploy the build to the production environment. And everything is done, right, product will go live. And that time also there might be maintenance activity there, or maintenance stage phases might be there, where like development team will provide the support for any kind of real time challenges, any workaround they will try to find, any kind of bug or defect is coming in the real like environment, they will try to fix it. and also they will try to enhance or customize the post release activity as well. So this is the different phases of the SDLC or software development life cycle. Now let's understand about the software architecture layers. So in most of the software, there are primarily three layers available: presentation layer, application layer, and database layer. So software architecture layers is nothing but it is used to organize code into horizontal specialized layer to separate the concern. The structure enhanced scalability, maintainability, and testability, allowing teams to modify one layer, such as updating the user interface, without affecting core business logic or data storage. As I told, right, there are primarily three layers. The first topmost layer is nothing but the presentation layer or user interface or the front end layer, it is called. This is the topmost layer, primarily used to manage user interface component, rendering data, and capturing user input, like just like a front end screen, right, where you can have some form, you can try to click on the link, you can try to enter some value in the input field, you can try to select a drop down value, you can try to check or uncheck the check boxes, you can select some value from the radio button, like you can try to interact with different images. So those are the kind of stuff you can do it, where you can look and feel the presentation layer, you can interact it. So what user sees and interact with, that is nothing but the user interface of the UI or the presentation of the front end layer. Example is like login page button, from links, etc. Then in the middle of the presentation and database layer, there will be one more layer called application layer, where all the business logic will be written. So application layer act as a mediator between the presentation and database layer, processes user input, applies different rules, and coordinates actions. So what are the best example? Like in case you want to give some user ID password in the UI, right, or the front end. So okay, how it is behaving, how it is validating, those kind of logics will be there as part of the application layer, or all the business logic will be validated in the application layer. So they will validate the login credential is perfect or not. In case it is a fine, you can able to go to the home screen. Otherwise, it will throw you the error. In case you want to process some transaction, it will also validate by the application layer. So this is the logic will be residing in the application layer as part of the business logic. Then the last layer, it is called database layer or backend layer. So with the UI or the presentation layer and the database layer, application layer will be playing the pivotal role to do the connections. It will get the request from the presentation layer. It will process the request. It will transfer the request to the database layer, and from the database layer, whatever response it is getting, it will process and it will again revert back to the presentation layer. Okay, so database layer is nothing but the backend. So this is where the application's data is stored and managed. It consists of the database management system like DBMS, and the actual data storage such as relational database, example MySQL, PostgreSQL, Oracle DB, or NoSQL database like MongoDB. So couple of example is like storing customer detail, transaction history, right? All this stuff you can do with the database layer. Now let's try to understand these three architecture layer with a simple example. So most of us used to go to restaurant, right, for our party, for lunch or dinner, like that. So in case you went to restaurants, you will be able to whenever you entered, you can get some seat, your waiter might be coming, they can give you the menu card. So what you can get to know, you can just validate the different options available for that particular day with the price, and then you can have the finalized, and then you can give the order through the waiters. So you are the persons who is the UI layer or the front end, right? You are able to see the whatever available in the menu card, and waiter is nothing but the the application layer, which is trying to interact with the SAP, which is nothing but the database. So after that, you order it, so waiter will take the order and or take the request, and then he will transfer the request to the SAP, which is nothing but the database layer, the backend. After that, SAP will prepare the food for you, and then SAP will again hand over the food to the waiter, and waiter will hand over the food to you. So that is the way waiter will be communicating with the front end and the back end. So back end is nothing but the the chef or the cook, whoever is preparing the food for you, and front end is nothing but the customer who is ordering the food. So most of the area, right, the user or the customer cannot directly interact with the chef or the cook person, right? They need to interact to the different application layer called the waiter or the store manager or the restaurant manager or supervisor, like that. So this is the different three-tier architectures of the software. Then let's understand about the popular SDLC model. There are a lot of models available to deal with the SDLC or software development lifecycle, like waterfall model, incremental model, V model, agile model, prototyping model, and spiral model. So let's discuss with one by one. So waterfall model works very well for the Molars project, where requirements are very well understood. The waterfall is widely adopted SDLC model. In this approach, the whole process of the software development is divided into various phases. In this SDLC model, the outcome of one phase acts as the input for the next phase. It is a linear, sequential approach where each phase, like requirement, design, code, must be completed before the next phase begins. So that is the reason the lot of drawback is there. So you cannot start the next phase until the first phase is covered. That is the reason nowadays people are going for the agile methodology or the models where development testing can done parallelly instead of waiting for long. So what is the main drawback for the waterfall model? Suppose say in case I want to divide the project total project tenure as 1 year. Okay, so like requirement for 1 month and development for 6 months, testing for 4 months, and then release for 1 month. But in case your requirement is getting delayed, your development will be delayed. In case development is getting delayed, your testing will be delayed. Your testing is getting delayed, your deployment will be delayed. That is the main drawback of this linear or sequential approach. That is the reason most of the nowadays we are using the agile methodology or sometime hybrid methodology, where we can follow the combination of waterfall or the agile methodology. Then incremental model. The incremental model is not a separate model. It is essentially a series of waterfall cycles only. The requirements are divided into groups at the start of the project. For each group, the SDLC model is followed to develop software. The SDLC process is repeated with each release, adding more functionality until all the requirements are met. In this method, every cycle acts as the maintenance phase for the previous software release. Modification to the incremental model allows development cycles to overlap. After the subsequent cycle may begin before the previous cycle is complete. Okay, so that is the incremental model. Step by step, you want to increment. One step will be completed, all the activity, then you'll go for the next step, and then next step, like that. So previous step will be treated as a maintenance first for the next phase here in the incremental model. Then V model is like the V, right? V sign of the alphabet sign V. Okay, so as an extension of the waterfall model that pair every development phase with a corresponding testing phase, forming a V shape. It emphasizes early test planning and high reliability. In this type of SDLC model, testing and development will be going in parallel. So there are verification phases on the side and the validation phases on the other side. V models joins by the coding phases. So V model can be also very enhanced part of the waterfall model, where testing and development can run parallelly, and that might be very popular strategy nowadays, right? To handle to deal with the any kind of schedule or effort variation, or maintain the overall project budget or overall project schedule. Other popular model is like agile model. Now this is very very popular model. So Scrum is one of the methodology in the agile. So agile methodology is a practice which promotes continuous introductions of the development and testing during the SDLC process of any project. In agile method, the entire project is divided into small incremental builds. All of these builds are provided in iterations, and each iteration lasts for 1 to 3 weeks, or maybe maximum 4 weeks. In agile model, every sprint there is a demoable feature to the customer. Hence, customer can see the features whether they are satisfying their need or not. Each releases are thoroughly tested to ensure software quality is maintained. It is used for the critical application. So instead of the waterfall model, in case you are using agile model, so think about the 1 year. So waterfall model, like one month for the requirement, 6 months for the development, like 4 months for the testing, or 1 month for the release. But here, this 12 month we can divide into multiple sprint, and one sprint can went for 1 to 4 weeks. So every sprint will be having some small functionality to be implemented, developed, and tested everything. After that, so instead of waiting for the 1 year, and instead of like our project will be going in trouble, we can divide into smaller sprint, and every sprint will be having some milestone, and we can try to achieve the milestone for every sprint instead of waiting for the last moment. And any kind of feedback suggestion, which we can also discuss it instead of any last moment waiting, and every that feedback we can incorporate it, and that is the way based on our learning we will try to make all this corrected in the upcoming sprint or the releases. And that is the way constant feedback like factor will be there, right, to discuss with the different stakeholders in the agile models. Then prototyping model. So prototyping model is a software development model in which prototype is built, tested, and reworked until an acceptable prototype is achieved. It also creates base for to produce the final system or software. It works best in scenario where the project requirements are not known in details. It is an iterative trial and error method which take place between the developer and the client. So whenever sometimes customer is giving work, they are not having any clear requirement. Okay, so you cannot go for the full fledged development. Instead of that, what you can do based on the like developers knowledge in this domain or in this technology, based on the whatever small document they have received, they will try to develop a prototype. So prototype is nothing but the sample working, I could say that software, right? Very sample with the very important key features, and they will try to present it after the customer can or the stakeholder can review it. They can give the feedback, and they can try to have a close discussion with the respective development team or the other relevant team, and they can get the idea. After that, they can proceed with the actual requirement refining, and definitely development team also can proceed with the further development using the prototype, or any kind of changes also that can be also accommodated in the prototype. The last one is called spiral model. There might be a couple of more models there, but I have tried to just add these important 6 models. So the spiral model is a risk driven process model. This SDLC models helps the team to adopt element of one or more process model like a waterfall, incremental, etc. This model adopts the best features of the prototyping model and the waterfall model. The spiral methodology is a combination of rapid prototyping and concurrency in design and development activity. So these are the very key important popular SDLC models we can follow as part of our software development lifecycle. Now let's start about what is software testing. We learned about the software development so far. So what is software testing? So software testing is nothing but the important process of evaluating and verifying that software product or application does what it is expected to do. So whenever you are saying what it is expected to do means that whether it is working based on the requirement, because requirement is the viable for the development or testing team. Development team is to develop their code using the requirements. Similar testing team also try to test all the key important validation either through different testing approach to make sure that all the requirement is matching in the required software. So it testing involves execution of software or system component using manual or automated tools to evaluate one or more properties of interest. The purpose of software testing is to identify the error, gaps, or missing requirement in respect to the actual requirement. It involves both verifications, where we are verifying that are we building the product right, and validation, are we building the right product. These are the two activity testing team will perform to identify defect or bug early in the development life cycle, and definitely it will help to improve the software quality and the mitigate the different kind of risk. So validation is nothing but concerned with checking that the system will meet the customer actual need. Validation is an extremely subjective process. It includes activities like requirement modeling, prototyping, and user evaluation. So validation mostly done during the development phase. So they will try to do the different static reviewing and other couple of process, like to make sure that they are going in the right direction to develop the product. Okay, that is the reason it is called, are we building the right product? Whereas validation, it is called, are we building the product right? So after the development is completed, as part of the verification, like testing team of the QA team will try to perform all kind of testing to make sure that the product is meeting all the requirement. So verification is concerned with whether the system is well engineered error free, and so on. Verification will help to determine whether the software is of high quality, but it will not ensure that the system is useful. Verification includes all the activities associated with the product, high quality software, testing, inspection, design analysis, specification analysis, and so on. It is relatively objective process. So now let's understand why software testing is really required. We are already developing the product and development team also doing the unit testing. Still, why different kind of functional or non-functional testing is required before releasing the product to the actual production environment. So software testing is very crucial, and because of the couple of key important reasons, like detecting the bug early. So testing will help identifying the bug and issue early into the development cycle. It will definitely, after, in case you are able to identify the bug at the earliest, it will reduce the cost and time of fixing them instead of identifying at the later phase. Quality assurance and reliable quality assurance and reliability. Testing ensures the software functions as expected, offering a stable and smooth user experience, providing confidence in the product stability and the performance. So this is the key objective of the quality assurance and reliability. Then security assurance. Security testing ensures the software is free from like vulnerabilities, especially critical in banking, healthcare, and the e-commerce app. In case your software is not vulnerable properly and anybody can create a threat for the you, anybody can hack, it will be a problem. So that is the reason you need to make sure that we are dealing with the security also, and make sure that it is very secure. Customer satisfaction, because at the end of the day customer is the key user, and you need to make sure that all customers are happy, otherwise there is no objective of your software or the product. So delivering a bug free smooth user experience increases customers trust and satisfaction. Then validate the requirement. That is the reasons we are primarily doing the testing. We need to make sure that all kind of requirement simply we are validating it, and all the requirement software is matching. So testing confirms that the application meets both functional what it should do and non-functional how it should do requirement. And after that you can certify that is all the functional and non-functional requirement is met. Now you are ready to go for the production deployment. Software testing reduce maintenance cost. So well tested software is less likely to fail, reducing future maintenance and support cost. Improve performance. Testing can identify performance issues like speed, responsive, so that can be optimized before release. So in case your software is good, software is secure, software is very user friendly, and software is all the functionality implemented, but software is very slow to use, uh, very slow for to use by the end user. So what is the point of the software, right? Nobody will be satisfied, and they will be creating a lot of trouble because of slowness. So we need to make sure that the performance also improve and it is up to the standard of the normal way, and it is maintaining the proper standard. Then compliance and safety. Testing validates that software complies with the industry standard and safe regulations, crucial for preventing catastrophic failure in critical system. So that is the very key objective, because whatever you are doing, your performance is okay, all secured. But still, in case you are not able to follow the market standard, right? In case you are working in the automobile sector, so definitely whatever automobile software you are developing, they need to just follow the local automobile sector specific to country, specific to region, specific to state if required. Otherwise the software cannot be useful, right, much, right, for the bigger area. Then let's understand what is error, fault, and failure. So error is nothing but human actions which will produce an incorrect result, whereas fault is nothing but the manifestation of an error in software or implementation, and failure will come whenever fault is there and you are not rectifying. So failure is nothing but the deviation of the software from its expected delivery or the service. So a human being can do any kind of mistake which produces a defect or fault in the code or in the software application of the product. If the defect in the code is executed, the system will fail to do what it should do, causing a failure. That is the reason you need to handle the error at fault to prevent the failure. So just giving an example. So all human being, right? So in case we are starting our career outside our hometown, we are staying in outside maybe with friend or the PG, right? And right, we are habituated that like we are taking very unhealthy food daily outside, and we are not doing any proper lifestyle, and we are not doing proper exercise. So what will happen after a couple of years, couple of months, we will be having some trouble in our body. So this is the error. So because of circumstances or because of our choose a lifestyle or the food habit, we are creating the trouble or error in our body. Okay. So because of that, like the fault will be coming in the body. Like there will be some lot of problem in the body, might be gastric problem, like other problem, right? Headache, right? Migraine issue. All this stuff will happen in as part of the fault. So what you need to do in case you are having some fault? What you need to do? You need to go to the doctors. You need to go for some the test. After that you need to go for some medication, like any kind of medicines, or you need to change your lifestyle, you need to go for some exercise, right? Then it can be recovered at the early stage, so that as and when you are able to identify the issues early, it will be very, and if you are fixing it, you are following the lifestyle properly, it will be very good. But in case still because of the problem, still you are continuing the same lifestyle, and you are not going to doctor, or you are going to doctor but you are not listening to them, you are not taking the medicine, that will create very, very big trouble for you. Your liver might be damaged, it can create some issue in the heart or other area, and that thing, it will be, if you want to rectify it, if you want to solve it, it will be more and more time consuming, more cost will be involved also to do it, and sometimes failure might be also happen. So this is the way, like error, fault and failure are linked in our real time as well, or real life as well. How can error occur in the systems? So we all human beings, and we can do some simple mistakes. So human beings are all prone to making simple human error. So that is the way we can produce the error. Miscommunication, the poor requirement, where there are a lot of person working on a particular software, but communication gap is there, or requirement is not properly documented, right? Sometimes you are not having the proper clarification session for the requirement, and without properly understanding the requirement, you are trying to develop the code or test it also, right? So that is the error can occur in the system. Working under pressure such as tight deadline, budget restriction, conflicting priority. Whenever sometimes like we are working under very tremendous pressure, we have to fulfill the deadline at any cost, though because of instead of so much delay, right? There are conflicting priorities. Some persons working on the other priority, or couple of different other sub project or other way. So this is the area also, like error can occur. Sometimes the complexity is more in the technology, complexity of the technology or the infrastructure, which like the team is not able to understand. So this is the also one of the way error can come in the system. Then poorly documented code with the proper review. So whenever any kind of development is happening, like need to make sure that it is reviewing by the peers, lead, manager of the customer. So that is the we can correct it. But in case review is not happening, like say like developer is really new, or they are the junior folks, they can try to develop their way, which are not following the best practices, and also the quality is not good. Because of that, also a lot of error can come in the system. Due to the environment conditions, sometimes proper environment is not there, like to do the development, testing in other way. So because of these are the important key aspects, like error can come into the system. Now let's understand about the software testing key principles. So whenever you are like working as a software tester, you need to understand all the key principles, like before starting your journey as part of your software tester, whether automation or the like manual tester or the performance tester, does not matter. So all the tests should meet the customer requirement. So customer requirement is a viable, and as a testing object, as a test, like in case you want to perform the different kind of test, you need to maintain that the requirement, and you need to follow all kind of testing using the customer requirement only. You cannot deviate anything from the requirement. Software testing should be performed by an independent third party. That is the reason testing team concept came as separate entity. Otherwise, development team can do the testing, but their mindset is still same, right? So, like different mindset will be creating different idea, and testing team is having their own unique idea, and they can do different kind of permutation, combination, positive, negative testing to break the system to find out the error at the earliest possible. Exhaustive testing is not possible, as we need to optimal amount of testing based on the risk assessment of the application. Sometime, right, due to the time constraint, other priority, it is not possible to do the full-fledged testing. So what we can do, we can go for the RBT approach or the risk-based testing approach, where we can try to prioritize our test case or test scenario or the like requirement, and we can try to do the more testing focusing on the critical area, then you can go to the high priority area, then medium, and if time permits, the low critical area. So that is the way still we can certify the product instead of time crunch or instead of any kind of delay. All the tests should be conducted before implementing it or before releasing the product into the into the production environment. So testing should be performed step by step, okay, and all testing should be completed properly before products your product is going live. There is no point of doing any kind of testing in case product is already deployed in the production environment. That time you're finding the error, there is no much usefulness. So testing teams should try to identify the issues at the earliest phase as possible, so that fixing the defect cost or effort will be can be minimized. It follows the Pareto rule or 80-20 rule, which states that 80% of the error will come from the 20% of the program component. So that is very true in most of the software. So in case you are having good experience, you can easily understand what are the critical functionality from the application specific to requirement or specific to the customer, specific to your project, and you can identify those requirement or the area, and where you can try to give more focus to do all kind of testing or penetrate the testing, and hopefully 80% of the program defect can found from the 20% critical area. Start testing with smaller part and extend to the large part. So we need to start the testing for the smaller part. That is the reason whenever development team is doing the development, they used to start with the unit testing. After that, we can go with the integration testing, all the component integrated. Then we can go for the full fledged end to end or system testing. Then you can go with the UAT testing. That is the way we need to start. We cannot directly jump to the end to end or system testing or UAT testing. Instead of that, we need to certify that other small testing is also working. Then we can go for the full fledged testing in case in case project is not so small. Early testing saves time and money. So in case you are able to start all kind of testing at the earliest possible, we can definitely try to find the issue at the earliest, and that is the way we can save the time and the money, or you can reduce the cost of the program or the software. Then we already understood about the testing, the key important benefit of the testing, the critical testing principles. Now let's understand about the testing life cycle or software testing life cycle or STLC, just like the SDLC or software development life cycle you already learned. So it will be series of stages, okay, like the requirement analysis, then your test planning, test development, then test environment setup, test execution, and test cycle closure. That might be more in the intermediate, is the intermediate between them, but mostly testing follows these six key important stages. Okay, so software testing life cycle or STLC is the testing process which is executed in systematic and planned manner. In STLC process, different activities are carried out to improve the quality of the product in consist of the following important key phases. The first one is nothing but the requirement analysis. In this phase, QA team studying the SRS of the software requirement specification, BRD or the business requirement specification, BRS or the business requirement specification, BRD or business requirement document, SRD or software requirement document, or sometimes user story or the US also from a testing perspective. They communicate with various stakeholders to clarify questions about the testability. They also evaluate the possibility of the automation. So whenever they are going through for the first stage of the requirement analysis stage, they will go through all the artifact, right? They will analyze it. They will understand with the product owner, scrum master, or the subject matter expert that what can be tested, what cannot be tested, any kind of query, they can resolve it right before going for the test planning also. Okay, what are the deliverables? Are the part of the requirement analysis phases where QA team or the quality assurance team or testing team will list out all testable requirement, and they will create a automation feasibility study report or the automation POC also, or the proof of concept. Then next phase is test planning. In this phase, test manager or the test lead will primarily prepare a detailed plan for testing. Activities include determining the testing strategy, choosing the automation tool, and resourcing planning. So key deliverables are from this phase is like test strategy, then test plan, test effort, and cost estimation report. The next phase is test case development. Once our test planning is done, we'll go for the test case development. So immediately we cannot go for the test case design, right? First we need to prepare the test scenario. Then we can review the test scenario with the business stakeholder. They can give the sign up as part of the normal process. After that, we can try to design the test cases. We can try to identify the test data. We can try to prepare the requirement testability matrix. So all this will be done as part of the test case development phase. So in this phase, tester prepare test cases, test automation script, and test data. Peers and teams lead review the test cases once they are ready. The requirement testability matrix or RTM, which maps the requirement to the test cases, is also prepared in this phase. The RTM is the vital document that helps in verifying the test cases have indeed been written for all the requirement, and also RTM can give the test coverage that all the requirement is covered, there is no gap. So deliverables from this test case development page is nothing but the test cases, test automation script, and test data and RTM. And now next three important phases of the STLC process is nothing but the test environment setup, test execution, and test closure. So as part of the test environment setup, once your test development is done, like your like development also completed, so in this step the QA team set up the software environment based on the hardware and software specification. If the software is multi-platform, the team will create multiple such environment. If the software system is ready, tester can also perform mock test to verify the validity of the test environment. With the basic high level testing, they can do that. All the basic end to end happy path flow is working in the testing environment, and before proceeding to the further all kind of testing. So what is the deliverable for the test environment setup? Configure test environment setup documentation, smoke test result, environment management and maintenance plan, right? Also there, how like environment they need to like manage it, any kind of environment downtime, how they can handle it, how they are planning to release the code into the environment, and what is the plan for the complete maintenance also. Once your test environment setup is done, your smoke test is almost passed, then you can go for the full-fledged testing as part of the test execution phase. Like the test team start executing the test cases based on the test plan. Test cases are marked as pass or fail, and the corresponding defect report are prepared and filed in a bug tagging tools. Bug tagging tool can be anything like Jira, Rally, ALM, Azure DevOps, etc. Okay, some modern test management tools can automatically file bug with relevant details when tester marks a test cases as passed or fail. Once the test case is complete, the product manager will determine if the defect are accepted or if another round of testing is required, in which case tester will retest once development fix the bug. So there are a lot of functional non-functional testing activity will go as part of the test execution. I will discuss in the next slides what are the different kind of test functional and non-functional testing we can do it, like if your requirement is there, if your customer agrees, or if the budget is there. What are the test deliverable from the test execution phase? Test run execution report, defect report, test log, and definitely QA team can share the like daily or weekly report to the respective stakeholder. So these are the deliverables. Now last step is called test cycle closure or test closure activity. So once all the critical issues has been fixed and tested, whatever encountered or whatever identified as part of the test execution, testing is said to be completed. The test team analyze test artifact like test cases for improvement in the future or other project or future release. A final test closure report that includes all the test metrics of interest is prepared and signed off with the customer. What are the key deliverables from the test closure phase? Like test summary report, final defect report, and lesson learned document. What are the challenges you faced? What are the lessons you have learned? What are the like solution you have implemented? What are the different innovative ideas you have implemented? All these will be documented as part of the lesson learned document. Now, as part of the whole STLC process, what are the key like deliverable or test deliverable like QA team used to share with the stakeholder or the customer? Starting with the test strategy, test plan, effort estimation report, test scenario, test case or the automation test script, test data, RTM or requirement disability matrix, defect report, test execution report, different metrics or the graph, test summary report, test incident report, test closure report, release note for all kind of minor or major release, installation or configuration guide, user guide for the end-to-end like flow of the applications, test status report, weekly status report, project manager or to the client. These are the different deliverables like testing team need to share with the respective stakeholder or the customer. There might be a couple of more, but these are the very main key test deliverables by the QA team. across the STLC phases. Now let's understand about functional and non-functional testing type. So what is functional testing? So in simple word, what the system actually does is called functional testing. To verify that each function of the software application behaves as specified in the requirement document. Testing all the functionality by providing appropriate input to verify whether the actual output is matching the expected output or not. It, it fails it falls within the scope of black box testing, and the tester need not concern about the source code of the application. In the real world, there are primarily black box, white box, gray box testing is there. In the black box testing, you do not understand about the code or internal logic. Instead of that, from the UI, like user will try to perform all kind of testing, and testing team will go with the all different kind of functional testing one by one, like unit testing, smoke testing, integration, system, unit testing, regression, and sanity testing. Okay, there might be a couple of more testing also there as part of the functional. We'll discuss later in the upcoming session. So unit testing, primarily unit testing is done by the development team. Unit testing is also called the module testing or component testing. It is done to check whether the individual unit of the module of the source code, like method or function, is working properly. Okay, it is primarily done in the develop by the developer in the developer environment whenever they are trying to trying to have small code, small unit. They can try to perform the testing to verify that all their unit is working as an isolated way properly or not. Any issue they can try to identify and fix it by themselves. So this is the different part will be there for part of the unit testing. Then so one unit testing is done, developer will deliver the code to the QA team in the, and they will release the code, right? They will release, they will do a release in the QA environment as well, so that testing team can start their basic testing in the QA environment. Okay, all the environment I'll discuss in the upcoming session. You don't need to worry. So what is mock testing? So a preliminary quick test performed on a new build to verify that the most basic and critical functionality are working, ensuring the build is stable enough for further testing. So mock testing is done to make sure if the build like a QA team received from the development team is testable or not at all. It is called also a day zero check. It is done at the build level. It helps not to waste the testing time to simply testing the whole application when the key features did not work or the key bug has not been fixed. So this is kind of high level testing before penetrating to the deep level testing, other testing. So QA team will do the high level happy path flow testing to make sure that all the basic functionality working or not as part of the smoke. In case not working, they will halt the execution for the other remaining testing, and they will report the bug, and then again like development team will fix the basic bug, and QA team will proceed to the other kind of testing. Then integration testing, after individual unit are tested, your smoke test is fast. Integration testing type will verify that the integrated module or the component are working perfectly together as intended, and that their interface also correct. It's primarily focuses on validating the interaction, data flow, and interface between combined components such as database, API, or service to uncover different key defect or bug. Then once integration is successful, we can go with the system testing, where we can also go with the end-to-end testing. So testing the fully integrated application to evaluate the system compliance with the specified requirement is called system testing. Verifying the complete system to ensure that the application work as intended or not. System testing is carried out by the specialist tester or intended tester or independent tester. System testing should investigate both functional and non-functional requirement of the testing. It is a comprehensive black box testing phase that validates fully integrated software application against its original requirement. It verifies the system's overall functionality, performance, and security in a production-like environment, ensuring all components work together seamlessly before final release. So here, all kind of end-to-end testing and non-functional testing also will be performing. Need to make sure that product is meeting all most major of the requirement, right? So that is the key object of the system testing. Then once all testing is done, then user can go for the end-to-end testing, the UAT testing or user acceptance testing. This is primarily done by the end user or the customer. So UAT is also known as the pre-production testing. This is done by the end user along with the tester to validate the functionality of the application. After successful acceptance testing, formal testing conducted to determine whether the application is developed as per the requirement or not. It allows customer to accept or reject the application. The key important testings will be done as part of the application acceptance testing or user acceptance testing or unit testing is called alpha, beta, and gamma testing. I'll cover what is alpha, beta, and gamma in the upcoming sessions. Then two more testings also like key important testing team can done called regression testing and sanity testing. There might be other more testings also available. You'll be getting to know in the upcoming session. No need to worry. So regression testing is essential testing type involves rerunning previously executed tests to ensure that the new code changes, bug fix, or update have not negatively affected existing functionality. It is repeated testing of an already tested program after modification to discover any new defect introduced or uncovered as a result of the changes in the software being tested or in another related or unrelated software component. Usually, users do regression testing in the following cases, like whether new functionality were added to the application or any kind of CR or change request has been happening or change requirement is happening in the project, any kind of defect fix is happening, any kind of performance issues fixing is happening, any kind of environment is happening like updating DB or updating the programming language, all this stuff is happening. Okay, so whenever this kind of thing happening, right, there might be chances that existing thing also can broken along with the new defect. So as part of the regression testing, primarily QA team will certify that because of the new changes, existing thing is also working fine. They are not getting impacted or getting like new defect is getting introduced. So sanity testing is done during the release phase to check for the main functionality of the application without going deeper. It is also called a subset of regression testing. It is done after the it is done at the release level. User perform sanity testing when they do not have enough time for regression testing. So sometimes like full-fledged regression testing is not possible due to the timeline, budget, and other factor or tester unavailability or the automation test script unavailability. So user can like tester can go for the sanity testing. So we can subset of the regression test case can be executed to make sure that like basic high level functionality still not break down because of any kind of change request or the defect fix or any kind of new releases. Now, these are the very, very key important like types of functional testing we discussed. Now, let's understand what is non-functional testing and what are the key important non-functional testings also like exist in the testing world. So, non-functional testing is primarily evaluates a software application quality attribute such as its performance, security, and usability, rather than its specific functions. In simple word, how well the system perform is non-functionality testing. Main focus is to improve the user experience on how fast the system respond to a request. There are key important non-functional testings available as in the testing world called performance testing. Then we can have security testings, compatibility testing, reliability testing, usability testing, portability testing, compliance testing, and installation testing. Now let's discuss about the performance testing first and the different subtypes of the performance testing. So performance testing is a type of testing which primarily determines or validates the speed, scalability, stability characteristics of the system or application under test. Performance is concerned with achieving response type, throughput, and resource utilization level that meet the performance objective for the project or product. Okay, so main objective of the performance testing is that to make sure that your product, your applications or software is fast. Okay, they are able to handle different kind of load, different volume of the data. All this kind of thing will be done as part of the performance testing. So, couple of subtype as part of the performance testing is nothing but the load testing, test testing, soak or endurance testing, volume testing, spike testing, scalability testing, and capacity testing. So, what is load testing? It measures performance under an expected number of user or transactions. It is to verify that the system or application can handle the expected number of transactions and to verify the system or application behavior under both normal and peak load condition. So that is the way you can try to like make sure that how much load or transactions or number of user can handle like as part of the load testing. Then test testing, It pushes the software beyond this normal operation capacity to determine its breakpoint and how it recovers. It is to verify the behavior of the system once the load increases more than its design expectation. So, in the test testing, we will try to break down the systems with the more and more load, and we'll see how it's recovered to the original state. Endurance and shock testing. Running a system at high load for a prolonged period of time to identify the performance problem is called shock or endurance testing. The primary goal is to determine if the system can sustain a continuous expected load over a prolonged period, typically couple of hours or day also, without performance degradations or failure. So here we will try to go for maximum load or high load, and we will try to maintain the load for couple of hours to a couple of days to make sure that performance downgrade is not happening for the software, or any kind of failure is not also coming. Volume testing, it is used to verify that the system or application can handle large amount of the volume of the data. Suppose say in case you are going on the e-commerce site, you could see a lot of transactions used to happen, right? So we need to store all the transactions. So large volume of the data we need to maintain, and need to make sure that because of the large volume, system performance is not downgrading. Spike testing, it evaluates the system behavior and ability to recover from sudden sharp increases and decreases in the user traffic or spikes. This is useful for testing scenario like flash sales or major event registration. So suppose say you already develop a software which suppose say maybe which can handle 1000 user, okay, but suddenly it might grow just like that. Any kind of flash sale, right, during some puja sales, during some celebration sales, like where that time lot of offers came into the, especially for the e-commerce site, and lot of people used to purchase it that time, your spike of the user or the transaction very very drastically change, and next day it might be drastically down also once the your end session over. So that is the you need to make sure that user traffic is also able to handle it as part of the pike testing. Scalable testing is nothing but it's a type of non-functional testing. It is to determine how the application under test scales with increasing workload. It accesses the application ability to handle increasing user demand or data volume by scaling its processing capacity. So in case you develop the product, market or launch the product as a new or scratch, right, that time your product user might be less, but slowly, right, you need to make sure that how your product or software can be scalable to handle more user, right, it will not getting the stable. So you can know that your product is having the opportunity where a lot of users can be scaled up. So that is the way we can do the scalability testing. Then capacity testings, it measures the maximum number of user an application can handle while still meeting predefined performance goal or service level agreement or SLA meets. So this is the different type of performance testing like load, stress, endurance or shock, volume, spikes, scalability and capacity testing. Now let's understand about the couple of more key non-functional testing type. So we'll go with the security testings. So, security testing identifies vulnerabilities and weakness to protect data and resources from potential threat and unauthorized access. These include techniques like vulnerability scanning and penetrating testing. The main objective of security testing is to determine whether the system protects data and maintains functionality as intended. Couple of important subtype of as part of security testing is penetration testing, vulnerability testing, and security auditing. So penetration testing simulates attack to identify exploitable gap in the security, whereas vulnerability scanning uses automation tool to detect known security flaws. Security auditing reviews code and configuration to ensure adherence to security standard and all the best practices. The next non-functional testing is compatibility testing, where user can verify that the software functions correctly, working properly different platform, devices, browser and operating system. It is to deploy and check whether the application is working as expected in different combination of environmental component. So here you can make sure that your system is working in the Mac, Windows, Linux, wherever possible. It is working in the different browser, Firefox, Edge, Safari, Chrome, etc. So this kind of testings you want to perform in the compatibility testing. Along with that, all the browser different versions, latest version also handle right by the application. Then reliable testing, it ensures the software can perform its specified function consistently and without failure under stated conditions for defined period. Couple of important subtype are recovery testing and failover testing as part of the reliable testing. So recovery testing assesses how well the system recover from failure or crashes, ensuring data integrity and prompt restoring of the functionality, whereas failover testing evaluates the transaction to a backup system during a primary system failure. Then usability testings, where focuses on how easy the system is to use from the end user perspective or the customer perspective. It will evaluate the user interface, navigation, and overall user experience. It certify whether the application is user friendly or not and was comfortably used by the end user or not. The main focus is in this testing is to check whether the end user can understand and operate the application easily or not. An application should be self-exploratory and must not require much training to operate it. Think about suppose say Gmail, like Facebook, right? Right, all this stuff, right? Or YouTube. So in case the end user is not liking the look and feel or not able to use it easily, what is the point of this application? In case application is good, but unless all the end user easily able to access it, there is no point, right? So that is the reason usability testing is really required for the end user or the customer standpoint. Okay, there are a couple of subtype as part of the usability testing is called accessibility testing and navigation testing. Through accessibility testing, like user will ensure the software is usable by people with disabilities, complying with guidelines like web content accessibility guideline or WCAG standard is also following. Navigation testing assesses the clarity and ease of moving through the application. Then we'll discuss about the couple of more non-functional testing type like portability, compliance, and installation testing. So portability testings primarily check the ease with which the software can be moved from one environment to other environment. Environment is nothing but the combination of hardware and software. Compliance testing confirms that the software adheres to relevant industry standard, regulation, and legal guidelines. Installation testing ensures the software install, update, or uninstall correctly across different operate in different environment without focusing on the application specific business features. It validates the user experience of setting up the software, including system compatibility and file configuration. So these are the very key non-functional testing like performance, security, compliance, reliability, usability, portability, compliance, and installation testing. Now, last topic from today, this session is like what is the key difference between the functional and non-functional testing type. We already understand what is functional testing, what are the key functional testing type, what is non-functional testing, what is the key non-functional testing types. Let's understand from the different aspects. So the main objective of the functional testing is to validate what the system does, whereas non-functional testing main objectives evaluates how the system perform instead of what system does. Okay, functional testings like business logic and features correctness will be validated, whereas non-functional testing using through non-functional testing, system performance, usability, security, and reliability will be tested. Okay, unit integration system or UAT testing will are the common key testing type from the functional testing, whereas load, trace, security, and performance testing are the very key testing type from the non-functional testing. In the functional testing, mostly like manual or automation testing can be possible, but whenever we are dealing with the non-functional testing, mostly automated with specialized tool we used to integrate to do the non-functional testing. So that's all from today's session. Stay tuned and follow the playlist for the other couple of video. Thank you.